During baseball practice, two players hit baseballs at the same time. The height of Brett's baseball is modeled by the equation where y is the height of the baseball in feet and x seconds after he hit it. The height of Andre's ball is modeled by the graph in the corresponding equation. So we are going to identify things like the maximum, the X intercepts, and the average rate of change. And please circle this portion. If you don't round your final answers to the nearest hundredth, unfortunately, I have to count it wrong. So let's start with Brett's hit. Please do second plus 719. Go to y equals and type in the equation you see. After you're done, we'll adjust the window and play with the window until we see a height and a distance that we can work with. So let's hit graph when you're done. I know it's a parabola. And okay, here, so I can't see much here. I'm going to open this up. Let's go. So we're looking at the height that the baseball goes. So let's try 100 feet up. I'm close, but not high enough. So now let's try and let's make it like 125. And again, I'm just playing with numbers on a specific number. I just want to make sure that I have some space up here. And also, as you can see, there's not much space here. It's going to make it difficult when I try to find the x-intercept. So I'm going to go and look at the y minimum and change it. I'm going to lower this number. It's at -10. I'm going to try like -30 or -40 just to give me more space at the bottom. Okay, the first question is what is the maximum height? Remember, height is a y value. It's not an ordered pair right now, it's a y value. I want to know this y value. So I am going to do second, trace, maximum. And then I'm going to follow the directions. Go left of the highest point. So somewhere to the left and press enter. Go up and over the highest point. Go somewhere to the right and press enter. And now go back and guess where the highest point is and press enter. So the maximum height is a y value. That's this value right here. We want to round to the nearest hundredth, which would be 103.52. 103.52. And is this in terms of feet, how high it goes? So Brett hits a ball right here. And we can see he hits it 6 feet above ground. So this is where Brett hits the ball. It's in the air, it's in the air, it's in the air, it's in the air, and then it drops to the ground. And the second question is how long is it in the air? This measures distance in feet. This measures time in seconds. So we want to know from here to here, what is this distance? So we're going to find the 0. Second, trace 0. The first direction says left bound. That means in this case above the x-axis. Anywhere above the x-axis, press enter. Second direction is go anywhere below the x-axis, press enter. And now guess where it is. Get as close as you can to the x-axis and press enter. Okay, so the x-intercept is 5 rounding to the nearest hundredth, 5.01. 5.01. And remember, this is time in seconds. So rate of change, we're going to use the slope formula. So it's the average rate of change from 0 to 2. These are both x values. So I'm going to put a 0 down and leave a space for the corresponding y. Put a 2 down, leave a space for the corresponding y. Now, how do you get the y values that are corresponding? Do second, trace, value. Second, trace, value. Type in 0, press enter. That means 0 corresponds with a y value of 6. Again, second, trace, value, and 2 corresponds with a value of 100. So I'm going to come off the side here, maybe up above where there's some space, and I'm going to use the slope formula. x1, y1, x sub 2, y sub 2. So substituting numbers, I have 100 minus 6 over 2 minus 0. 94 divided by 2. And 94 divided by 2 is 47. So it rises at an average of 47 feet per second. That's how fast Brett's ball goes up in the air, between 0 to 2 seconds on average. Okay, when you're done with this, please do second plus 712 on your calculator. And now we're going to do Andre, so I'm going to plug in this equation. Negative 15.72 x squared plus 66.45x plus 5. And we will have to adjust the windows again. So first let's just see what the graph looks like. Okay, so I need to go up quite a bit higher. Right now I'm at 10. Let's first try 100. 100 works, but as you can see, there's just not much space down here. So I'm going to move the Y minimum down to maybe like negative 30 or negative 40, just to give yourself more space. Okay, doing the same thing, we're going to start in this first spot with the maximum. I want to know what is the Y value in this position. Second, trace maximum. Go left of the highest, right of the highest, and directly on the highest point. Remember to round to the nearest hundredth. That's what the directions say up above. So 75.22 feet. That's how high it goes up. So Andre hits it here. It's 5 feet above the ground when he hits it. It's in the air, it's in the air, it hits its maximum point, it's in the air, it's in the air, and then it hits the ground. We want to know, what is this? How much time was it in the air before it hits the ground? So we're going to figure out the X intercept. Another word for X intercept is the 0. First direction is left bound. That means in this case above the x-axis, press enter. Go below the x-axis, press enter, and back on or as close as you can to the x-axis. And rounded to the nearest hundredth is 4.30 seconds. Average rate of change. So 0, we'll find out the Y, and 2, and we'll find out the Y. To figure out the corresponding Y values, it's simplest to use a calculator. Second, trace value, plug in 0. 0 corresponds with 5. And second, trace value, plug in 2, and 2 corresponds with 75.02. So I'm going to use the same formula that I used up here. I'm going to plug these numbers in. X sub 1, Y sub 1, X sub 2, Y sub 2. So 75.02 subtract 5 over 2 subtract 0. Okay, I'm going to use my calculator since we do have some decimals. 75.02 subtract 5. And now I'm going to divide it by, I know 2 subtract 0 is 2. So 35.01. That represents how fast the ball is rising between 0 to 2 seconds. So it's rising at an average of 35.01 feet per second. I'm not going to write in the answers, but we'll discuss them. Whose ball reached the highest height? Justify your answer. So we can see that Brett's ball hit a maximum height of 103.52 feet, while Andre's ball only reached a maximum height of 75.22 feet. That's one way to say it, one way to compare them. You could also subtract and say Brett's ball hit this feet, which is, maybe we could do it by going 103.52. Whoop. 103.52 subtracting 75.22. Another answer that would be acceptable would be Brett's ball hit a maximum height of 103.52 feet, which was 28.3 feet higher than Andre's ball. That's another alternative answer you could have where you compared them and also offered the answers. The second one, whose ball hit the ground first? So we want to know whose ball was in the air the shortest amount of time. And the answer is Andre's. Andre's ball hit the ground after 4.3 seconds, while Brett's ball hit the ground after 5.01 seconds. Your last question, part C, which is up above, further up above, but I'll read it out loud, said, whose ball travels faster? So remember, this is a speed. Whose ball travels faster over the first 2 seconds, between 0 and 2 seconds? And we can see that Brett's ball is traveling 47 feet per second up in the air on average, while Andre's ball is only traveling 31.0 feet per second. So this is traveling faster. The ball was hit harder.